This is Geometry, section 5.3, bisectors in triangles. So the first example we have here says to draw in the three perpendicular bisectors of the triangle at the right. So a perpendicular bisector is a segment that's perpendicular to another segment and it bisects it, so it's going to hit it at its midpoint. So if we have a ruler, this makes things a lot easier because we can measure how long the segment is and measure where the midpoint would be, but we'll just estimate where the middle of each of these segments is. Also, if we have a ruler, it's easy to make it perpendicular because we can put the flat side, the short side of the ruler along here, the long side going this way, and then we can make a perpendicular line, but we'll just do it the best we can. So if I make a perpendicular line through this point, it looks something like that. If I make a perpendicular line through this point, it would look something like that. And a perpendicular line through this point. This line is a little bit slanted, so my line is going to be a little bit slanted. So if you do this correctly, then these three lines should all meet each other at one point. So it says label the point where the three perpendicular bisectors meet as P. This is called the circumcenter of the triangle. So the point where all three perpendicular bisectors meet is called the circumcenter. It says measure the distance from P to each vertex. So again, if we have a ruler, that makes it a lot easier. So if you had a ruler and you measured in centimeters, all three of these would be about 4 3/4 or 4.75 centimeters. So this is actually in centimeters. So P is, since it's the same distance away, we call that equidistant. So P is equidistant to the vertices. So G, H, and S are called the vertices of the triangle. So P is equidistant to all three vertices or all three corners of this triangle. So the perpendicular bisectors theorem says that the three perpendicular bisectors in a triangle all meet at one point. And again, that's called the circumcenter. And this point is equidistant to the three vertices. All right, so since the three perpendicular bisectors will all meet at a single point, we really only need to find two of them, because the third one is going to hit the other two at the same point that the first two hit. So we really only need to find two of them to find that point that's equidistant between the three corners of the triangle. So we've got a problem here. It says Andy, Beth, and Carl live at A, B, and C, and gives the coordinates of A, B, and C. They're graphed on the graph over here. If they want to meet by walking in a straight line so that no friend has to walk farther than the others, where should they meet? So it's basically asking us find the point on here that's equidistant from A, B, and C. So step one, we've got to find the perpendicular bisectors. So the first thing we need to do is find the midpoint of AB. If we look at the coordinates of AB, 11 and 15, I need to take the average of that. If I take the average of 11 and 15, that gives me 13. If I take the average of 14 and 12, that also gives me 13. So 13, 13, this point right here is the midpoint of AB. Now we have to find the slope of AB. Well, if I count from this point from A to the midpoint that I just found, I'm going down 1, right 2, so that would be a slope of -1/2, or -1/2. So the slope of a line perpendicular to AB, because we're trying to graph the perpendicular bisector, would be the opposite reciprocal of this, so it becomes +2 over 1, or just 2. So now drawing the perpendicular bisector, we know it goes through this midpoint, and the slope is 2, so I can either go up 2, right 1, or down 2, left 1. I'm going to go down 2, left 1 a few more times because that's going to tell us where these lines are going to meet. Okay, so we have to do the same thing for AC. We've got to find the midpoint. So if I look at the coordinates of AC, the x-coordinates are 11 and 3. The average of that, 11 plus 3 is 14 over 2 would be 7. So the midpoint would be 7. and 14 and 6 added together is 20, divided by 2 is 10. So 7, 10 is going to be our midpoint of AC. The slope of AC, so if I count from C to this next point, or this next point, or this next point, or this next point, it's going up 1 over 1 each time. So the slope is 1. The opposite reciprocal of 1 is just 1 over 1, so the reciprocal is still 1 over 1, but I need to make it negative. So it's going to be going down this way, down 1 over 1 for the slope here. So if I keep doing that, eventually I'm going to hit at this point right here. So this point right here, which has coordinates 10, 7, is going to be our meeting place, which is equidistant between all three of these, A, B, and C. Verify using the distance formula that the distance from A to that point that we just found, B to that point, and C to that point is the same. If we plug this in the distance formula, we get that each of them is the square root of 50. If you need help on the distance formula, please see one of the previous videos. Okay, another example. So in triangle CAB, BQ and AQ are angle bisectors. So these dotted lines are angle bisectors. It says explain why YQ is congruent to XQ. So we learned in the last section that a point on an angle bisector is going to be equidistant to the two sides that make up that angle. So this point on the angle bisector is going to be the same distance away from this side as it is from this side. So each of these has to be 5. So that's just the angle bisector theorem that we learned in the last section. Explain why XQ is congruent to ZQ. This is the same reason, except now we're talking about this angle bisector. So Q is also on here. It's going to be equidistant to this side and this side. So same reason. Explain why YQ is congruent to ZQ. So we don't have an angle bisector over here, but now that we've said these two are congruent and these two are congruent, this is just transitive property or substitution. So since YQ congruent to XQ, XQ congruent to ZQ, YQ and ZQ are congruent. That's the transitive property. So ZQ would be 5, AX would be, let's see, AQ, it gives us, so AQ would also be 5, so these are all 5. ZQ, oops, sorry, AQ is this one. AQ would be, we have to find AX first. So AX we can find using the fact that this is 12. This piece would also be 12. So AQ we need to find using this triangle here. So to make things a little bit less crowded, we've got A, X, this is a right angle, this is Q, this is 12, this is 5, so we need to find this piece right here. We have not done this in class yet, so these two sides we would call A and B. This side we would call C. Don't worry too much about this part, since like I said, we haven't done this in class yet. So if you've got a right triangle, you can add up the 3 sides of it. So this is the longest side across from the right angle. We call that C. We call the other two A and B. So we say that A squared plus B squared equals C squared. 5 squared A, B squared was 12 squared because B is 12. C we're trying to find. So if I add up these 25 and 144, I get 169. Take the square root of C squared to just turn it into just C, and then the square root of 169 would be 13 here. This part down here is just extra credit in class, so that's it.